This is January 07 and this is question 1. Table 1.1 lists a number of quantities. Complete the table by placing a tick in the appropriate box to indicate whether each quantity is a scalar or a vector. So that's very similar to the previous year's question as well. And so density, first of all, well, density is mass divided by volume. Mass is a scalar and so is volume, so that must be a scalar. Momentum is mass by velocity, and velocity is a vector, so momentum is a vector. Temperature definitely has no direction, it's definitely a scalar. Kinetic energy also has no direction and it's a scalar. Displacement is a vector because it has direction. And speed is also a scalar. Part B. A car and its driver have a total mass m. It moves up a slope inclined at angle theta to the horizontal as shown in figure 1.1. Write down expressions for the magnitudes of the components of the weight of the car and its driver normal and parallel to the slope. So the first thing we're going to put in here is a vector representing W or mg, big mg, the weight of the car. There it is there. Now we then have to draw a right angle triangle to represent a vector or a component of the weight vector which is perpendicular to the slope or normal to the slope, and then also one which is parallel to the slope. And the angle theta is always found in between the weight vector and the one which is normal or perpendicular to the slope. And therefore the components here, this is the one beside the angle, so this is the one which involves cos, so it's mg, the cos of theta. And then this one here is opposite the angle, so it involves sine, so it's mg, the sine of theta. And you should always, of course, put the arrows in when you are drawing that, if you can see that. So the component normal to the slope is the one at right angles to the slope, so that's the mg. Sorry, I've said that again. The one which is normal to the slope is the one at right angles, so it's mg, the cos of theta. And the one which is parallel to the slope is this one here. That's mg, the sine of theta.